Okay, so you see, okay, we fill in this table first. So this guy, mass 60 kg. So mass 60 kg, okay, if I ask you to draw the forces acting on him, what are the forces acting on him? Obviously, the most obvious force. Weight. How much is his weight?
600.
Yeah, 600. So you write here 600. Air resistance short formula, I just write AR. Okay. Now, so this guy, table here, okay. Gravitational force acting on body, like you said, that is the definition for weight. Just upon release, what's the value? 600, right? Does it ever change?
No.
Okay, so it's 600 when it's falling. Then when it reach terminal velocity or constant velocity, it is still going to be 600. Okay, air resistance. The moment you release, 0. Yes, because there's no air resistance, the speed 0. As the speed increases, it will keep increasing until you reach 600. And then when you reach 600, that is when you know what is going to happen. Okay, so the overall force
600.
here is 600. Second box, increase or decrease?
Decreasing to 0.
Decreasing to 0, yes. Decreasing to 0. Then Dylan, finally, when it's equal to each other, the two forces, that means the overall force is 0. Okay. So the acceleration upon release, Dylan, what's the acceleration? The moment you release, falling on Earth. So what's the acceleration?
10.
10 meter per second squared. As he falls, Shahir, this one, increase or decrease?
Decrease.
Good. And then over here, obvious is the 4 boxes. Dylan, the acceleration will be what? 0. Okay. Then the speed,
0.
just upon release, 0 meter per second. While he's falling, increasing. And then finally, when the resultant force 0, acceleration 0, Dylan, it means his speed is constant, correct. See? All very smart. Nobody to confuse you by the name of Jonathan.
I want his one to stop halfway. Like after
He's want to stop halfway, then after you go back up. Okay? That is, for him, that's what's going to happen. Okay, so while he's being baptized, you are falling down through the air. So you understand So the blanks here, I think you should be able to fill up So my first sentence,
air resistance at each.
Then Shahir, carry on.
At the moment the object falls, the speed is 0 and acceleration is 10 meters per second squared.
Dylan, carry on.
As the object falls, the speed is increasing, air resistance also increasing, and the acceleration is increasing. Wait, acceleration? As object falls, acceleration is also increasing. No?
Should be decreasing.
Increasing or decrease?
Decreasing.
Decreasing, yes. So approaching 0. Okay, then Shahir.
Eventually, the air resistance equals to the gravitational force acting on the body. The overall force is now 0, while acceleration is 0 meters per second squared. The object will then fall with constant or terminal velocity.
Yeah, constant terminal velocity. So terminal velocity simply means constant speed, okay, or constant velocity. So what does the graph look like? I think you also know what the graph looks like. The graph looks like
Up, then
flat.
far.
Up and then flat. Ask you, is it straight line?
Yeah.
Like that? Or is it like that? Which one you think is the answer?
Right now it's the second one.
Second one. Dylan, why? You are right, but why?
Like decreasing acceleration.
Yes, very good. Decreasing acceleration. Yeah. So it looks like this. Acceleration is decreasing because the air resistance is increasing. Then after that, terminal velocity. Okay? Good. Okay, so so you understand it all very well. That's great. So the proper definition is here. Everything in one sentence, and you notice it's basically the 4 boxes over there, right? Maximum constant speed, force motion equals force opposed, resultant force 0, acceleration 0. Okay, these are your 4 boxes, right? Okay, so use this word. Don't forget this word. Maximum constant speed. It's not just constant speed, but maximum. Okay, that is your terminal velocity. And terminal velocity cannot happen for a car. It's only for things you are free fall. Okay, don't say a car is going at terminal velocity. A truck is, I'm running at terminal velocity. No meaning one. Okay. Okay. So terminal velocity also depends on other factors like what things which can affect things which can affect the terminal velocity. What does it also depend on? It depends on, what do you think?
On
The weight. Yeah. Right. So if different person got different weight or different mass, right? It also depends on the mass of the object. Okay? Different mass. So who will reach terminal velocity faster? Somebody like Jonathan who is very light, or somebody who is very heavy?
Light.
The light one will reach terminal velocity first, right? Okay, so so sometimes they ask you they give you 2 graphs. They give you 2 graphs like that. Okay, so this one will be the smaller mass. Okay, then this one will be the larger mass. Okay, why? This one we can reach terminal velocity faster. Okay, like that guy was 600 kg, Jonathan only, or rather that guy was 60 kg, then Jonathan only 30 kg. Definitely the air resistance can reach 300 newtons faster, right? So the mass will affect, okay, the mass of the object. Who is heavier? Okay, what else? Okay, I wrote here the density of the medium. Density of medium means what? So it can be falling in air, or it can be falling in oil. Which one will reach terminal velocity faster? When you fall in oil or you fall in air? Air.
Wait, oil?
Why? Oil has a lot more resistance, right? Oil has a lot more resistance. So this one, okay. So for each one I need to draw one object. This is your denser, let's say you got the denser medium. Then this one, the less dense medium. Okay, because the denser medium is going to generate much more resistive forces, okay, than your less dense medium. Okay, one more factor. What do you think it is?
Can you like surface area?
Yeah, very good. See, very smart, even though you're half asleep. Surface area. Why do you say surface area? What does surface area affect?
Air resistance.
Yes. So okay, let's draw yet another graph. So let's say the 2 objects same mass, same weight. Which one will have a larger surface area? Which one will reach terminal velocity faster?
The largest surface area.
Yes, because it generates much more air resistance. So here, larger surface area. Then this one will be the smaller surface area. Correct. Good. Okay. So you see quite commonsensical but then again commonsensical also sometimes still get easily mixed up and explained wrongly. Okay, now you turn over the next page. Okay, look at this one. Okay, so you all understand the factors? How do you explain question 1? Okay, look at question 1.
Have a large terminal.
Okay, so you know the answer is A. A will have a higher terminal velocity. So how you explain? Since A
Since A has a smaller surface area,
has a smaller surface area than B, then what's the next point?
it will generate less air resistance.
It generates less air resistance. Okay. And what does that mean? And it means that so it takes longer time, okay, for the air resistance. I'm going to add in one more point first to equal the weight. Right? Hence it has a higher terminal velocity. Okay. Hope you can explain that yourself. Yeah, so next question is O-level question. Yes. And possibly part D is not so easy. Never mind, you all think about it. Part A, part B should be able to do lah. You try first.
maybe.
Okay, let's look at part A first. Acceleration from A to D. So acceleration from A to D. So Shahir, what's the answer?
Acceleration for A to D. Wait,
Describe no?
so I said like initially the acceleration is 10 meters per second square.
Okay.
After that, as speed increases from A to C, acceleration of the stone decreases as air resistance also increases.
Okay, good. Very good, complete answers.
Then from C to D, deceleration is constant because
You don't need to say why because they need asking you to describe the deceleration. Okay? Okay, you don't have to explain why. So that's actually not required. So you said
Must you see the at A the acceleration?
yeah, at A initially, right? At A, the moment you drop, right, the acceleration is 10 meters per second square, and then from A to C, the acceleration is decreasing, getting smaller and smaller because of your you say like air resistance. From C to D, the deceleration is constant. When did it hit the water? At which point? D. D or at C? C, right? Okay. Then the water resistance caused the deceleration to be constant. Okay, that one we talk later. So this is not too bad. Okay, now let's discover which one of you is correct and which is wrong. And now we become 11.4. Write the two lines. F equals ma. Then force motion minus force opposed equals to ma. What is the force motion? What is the force that causes it to come down? It is the weight. And what is the weight? 15 newtons. Do you write 15? Wait, Dylan, do you write 15?
Yeah.
You wrote? Huh?
I changed it.
You change it to 15. So the weight is 15. Air resistance is don't know. Call it AR. Mass is 1.5 times A, which is
3.6 newtons.
2.4 times 1.5, right? 3.6 ah? Yeah, correct, 3.6. Yeah lah, he's right lah. Hey, Dylan, how you get 6 point something? You minus wrongly ah. So 11.4 meter per second squared, right? Am I right? No, what meter per second? Newtons. Yeah, units, newtons. Okay correct Okay, so calculation quite okay Okay, now come to this one, part C. Wow, part C and D, especially part D, not so easy. Part C, you got to be careful when they ever ask you this kind of question. Explain in terms of forces acting why the acceleration decreases between A and B. You know, no? But how do you explain in terms of forces? When they say explain in terms of forces, what do you have to say? Okay, first you have to describe what are the forces acting on the object. So the first thing you do, describe the forces acting on the object. Okay. Yes. And you got to say acting which way? Up and down. Okay, so first line. Weight is acting downward from the object and air resistance acting upward on the object. Okay, so that is just describing what are the forces. Okay, so why the acceleration changes? You all know the acceleration is increasing or decreasing? Decreasing, right? From A to B is decreasing, right?
Yes.
Okay, so why
Air resistance is also increasing.
Okay, now see Okay look I teach you how to explain You look at this, you are very familiar with these two lines, right? So what you do is this. Like what shall I say? Say, because the air resistance is increasing, right? Then the weight does not change. Hence the resultant force is decreasing. So you follow this like a format to answer the question. First line you say what are the forces. Then next you say how does the air resistance change? How does the weight change? Then how does the resultant force change? And then as a result, how the acceleration changes. Understand?
So like basically as air resistance is increasing and the weight is like constant, that results in like the resultant force decreasing to zero, like hence
acceleration decreasing.
Acceleration is decreasing.
Yes, correct. Okay, yes, good. You just add in a few things. As air resistance is increasing, all this you know one. No. The problem is you don't know how to write it out, okay, or you miss out something. As air resistance increasing, why is air resistance increasing? Because the speed is. Okay, just say this. Okay. Okay, then Dylan, as air resistance increasing, then what's the next thing to talk about? Not yet. Don't skip. See, you have to talk. You talk about this, then you need to talk about this, then you not talk about this. Don't jump from here, jump to here. Okay, don't jump here to here.
The weight is the same.
Okay, the weight is the same. Yes. The weight remains constant. Okay, then what's next to talk about, Dylan? Jump to acceleration yet? Already not yet The resultant force is
the same.
it's the same.
No, it's decreasing.
It's decreasing. Okay, then finally, hence
The acceleration.
okay, and then why? Because F equals to ma. Okay, so Xiaohe just now said you said everything correctly. Just add in this because F equals to ma. So you see, important, because this is somewhat common for them to ask you, explain in terms of forces what is happening. So a lot of people will just jump. They will say, oh, air resistance increase, therefore acceleration decrease. In terms of forces means you must talk about this, you must talk about this, and you talk about this, and then finally this. Okay? So use this as your guideline to help you explain what is happening. Alright? Can I? Okay, now look at this one, the hardest one of them all. This, okay, a bit tricky. So if you look at part C, you think, oh, fall in seawater, reach terminal velocity. So is it exactly the same answer that as this one over here? This guy that's falling in free fall in air, is it the same?
Almost. But isn't it like this tunnel is in water, so there's no like air resistance that they only go up.
Okay, first difference is not air, it's water. Okay, so that's one difference. What else? It's not exactly the same. Some people are right exactly the same here. They describe the answer. Wow, they study very hard. Everything they write all come from here. Totally wrong. Because of something. Okay, one, yes, it's seawater now, but you look something about this. What happens? Okay, it's not so straightforward. Maybe you all can think and see. You see, when does it hit the water? It hits the water?
From C to D.
C, right? When C to D is inside the water, right? Hit the water at C. Then after that, speed went down. Then where is terminal velocity? Which part?
Same like the.
Where they reach terminal velocity? Here, right?
Yeah.
So this graph is strange, right? Whereas in this case, you see, is the speed increase and then terminal velocity. So this one, the speed what? Decrease and then reach terminal velocity. So it's the other way around. So how do you explain this? What's happening?
It's water, man.
Okay, so what is happening? Look, it hit the water at a very, very high speed, right? And then after that, the speed decreased. Why did the speed decrease? Because of what? Water resistance, right? Okay, now ask you, here at this point, speed maximum. You all agree with me? WR, water resistance. Maximum or minimum? 0 or very high?
High.
Very high, why? You're right, why? Because of what? Remember, I always tell you the resistance, air resistance depends on the speed. So, why is the water resistance maximum?
The highest the water resistance.
Yes. The speed is maximum, the water resistance also will be maximum, right? Okay, so you see the difference already. I hope you see the difference. This one was what? When it started here, speed was 0. Air resistance, 0. Then air resistance get bigger and bigger and bigger and bigger. Speed gets bigger and bigger and bigger. This is the difference. Then here, as it keeps falling, the speed. So here what happens? What happens to the speed?
Like I thought water resistance or air resistance.
The water in the water.
The speed decreases.
The speed decreasing, So you think, the speed decreasing. So the water resistance what? Increase or decrease? Decrease. Don't you realize it's the opposite? Just now is what? Speed increase, air resistance increase, right? So now is speed decrease, water resistance decrease. Correct, I hope you can follow, I hope Jonathan can follow, But I have a feeling not, Maybe you get baptized, Baptized means you know must go underwater. Maybe you experience terminal velocity.
The pastor slapped a tongue and hit the water at max resistance.
Okay, never mind. Okay, so when you come to here, what happens? Speed decrease, decrease, decrease. Water resistance decrease. Then come to here, what do you think happens? The water resistance now is equal to the...
Weight.
Correct. and then your 4 boxes, everything come in again. Understand? So this one is not easy question. A lot of people get it wrong because everybody is always thinking speed increase, air resistance increase. This is actually the other way around. Alright? Can follow or not? Dylan?
Yeah.
Can you all the whining, groaning, but can understand. Okay, so okay, so there's quite a lot to write, but how are we going to write everything out? Let's choose a color. What color is nice? Choose a color, Dylan. What color?
Green.
Green. Which green?
On top.
Okay, green. Okay, how do we start? How do you think we start? Where do we start?
You talk about forces acting on them first.
Okay. Which point do we start?
C.
Okay, start at point C. Okay. At C, okay, what are we going to say? The object speed is
Maximum. Wait.
maximum, right? Maximum when it hits the seawater. Makes sense, right? Because it's falling, right? So the moment it hits the seawater, it's very high speed. Okay. Okay, what else must we say? And what?
No, there is
And the water resistance 0 minimum or maximum?
maximum.
Okay, short form okay, I don't keep writing 2 words water resistance, I'll just write that WR is also maximum. Okay, so we start at C, we say this. Okay, Shahir, what will you say next? This one hit the water already. Then the next move after that,
Like speed is decreasing
describe what's happening to the object.
as the object lands into seawater.
Now it's in the seawater race, and what's happening to it?
Speed is constantly decreasing.
Okay, so okay. So as the object falls in the seawater, the speed is decreasing. Okay, the speed is decreasing. And then after that, speed decreasing means the
Water resistance.
And the water resistance is also decreasing. Okay. Okay, quite a lot to write. Then, okay, the most crucial part comes now. What is it? Eventually,
air resistance, not air resistance, water resistance is equal to the weight. So hence, there is 0 resultant force as 0.
4 boxes, you all say 3 already, and it falls with terminal velocity, or what we call constant velocity, or this is not maximum in this case, it's minimum. It's a constant velocity or terminal velocity. Okay. So eventually the water resistance will equal to the weight of the object. Okay, that's your box number 1. Can you imagine last time I had students, of course most people cannot do this question at all. Okay, all wrong. Then I got also a handful of students who can do it. And out of the handful, they write everything correct. Except for the word. They made a very crucial mistake. Instead of water resistance, they write what? Everything what a waste, no. but everything correct. Because keep thinking of air, it's actually water.
Yes.
What a waste, right? You write everything and then you write air. Aiyo, can cry, man. Okay, so eventually the water resistance will equal to the weight of the object. Okay, that is box number 1. So Shahir says box number 2 is
The resultant force is
box number 2. Okay. Didn't contribute box number 3. The acceleration will then be 0. Okay, number 3. And then after that, conclusion.
Constant.
Hence, the object will now fall with
Terminal velocity.
constant, or what we call terminal velocity. Okay, so that's your box number 4. So a lot to write, but can once you understand, you know how to write. The problem is don't leave out anything. Okay.